So our second speaker is going to be Gianna Bertuol Garcia, who's a master's student at the Universidade de São Paulo in Brazil. Her talk will be revealing viewpoints on the science-practice interface in ecology and conservation.
Okay, hi, good morning. So this work I'm presenting is part of my master dissertation, which was about the science-practice interface in ecology and conservation and how to develop more effective science-practice partnerships. And to do this, it's important to understand how science and decision makers think about this issue. So that's what I'll be talking about. So the relationship between science and decision making across different policy and management contexts is actually a contentious topic. Several theoretical conceptualizations of decision-making have been described in the political sciences, ranging from emphasizing science as the sole provider of relevant information to decision-making to assigning a minor role to scientific knowledge in a complex political process. In ecology conservation, this science-practice interface has also been the focus of intense debate. Scientists have been criticized for not helping to solve environmental problems, while practitioners have been criticized for not using scientific knowledge to support their decisions, leading many authors to argue for the existence of a science practice gap in the discipline. Within this debate, different conceptualizations of the science practice interface have been proposed, ranging from a linear model of science communication with a unidirectional flow of knowledge from science to practice, to integrative models of knowledge co-production, emphasizing instead bidirectional knowledge flows and integration of different knowledge types. In addition, controversies are common in the ecological and conservation literature. For example, the popular evidence-based approaches have been recently criticized for neglecting other types of knowledge, other non-scientific types of knowledge, and the intricate processes of decision-making. Overall, this suggests diverse understandings or opinions about the science-practice interface among scientists and decision makers. Understanding and making explicit this diversity of opinions is important as a key democratic strategy to deal with unequal power relations, to challenge hegemony of dominant models, and to assist identifying which mechanisms to link science and practice will potentially receive more support. This can be even more important in tropical developing nations, where there's high biodiversity, but also deep social, political, and economic challenges that threaten this biodiversity. However, increased investment in research and education has created opportunities to deal with these challenges. So in this study, we aim at understanding how science and decision makers in a tropical developing nation think about the science-practice interface in ecology and conservation by describing the different viewpoints and identifying possible points of consensus and conflict. We focus on Brazil as an example of a tropical developing nation with a growing science and where the role of science in environmental decision-making has recently received great attention. To identify the viewpoints, we use Q methodology from psychology. Participants were presented to a list of statements describing how the science-practice interface should ideally be. And then participants ranked their agreement with these statements on a ranking scale from -4 to +4, using a fixed normal distribution, so equal to this one in the picture. So the number of statements per category was the same for all participants, but they could differ on where each statement was allocated. And this difference, so the distribution overall represents the view of each participant regarding the science practice interface. To develop the list of statements, we rely on 3 conceptions of the science practice interface derived from the literature. So the first conception is an unidirectional conception that emphasizes scientists producing scientific knowledge, which is then communicated and used by decision makers. The second conception is an integrative conception, which also emphasizes the knowledge of decision makers that should be integrated with scientific knowledge. And the last conception emphasizes mainly scientists and scientific knowledge, so science should go to practice and put their results into practice. For each conception, we wrote statements describing the relevant processes, the important knowledge, the important actors, and the activities that should be promoted within the view of each conception. And this list was further complemented with sentences obtained from relevant articles and through consultation with decision makers, arriving at a final list of 48 statements. To select participants, we considered 2 pools. The first were active scientists in ecology and conservation science, for which we selected advisors within graduate programs. The second pool was of decision makers relying on knowledge from ecology and conservation science, for which we selected analysts from the Federal Environmental Enforcement Agency in Brazil. We used stratified purpose sampling. So for each of 5 Brazilian regions, we chose at least 2 scientists and 2 analysts. We also stratified by degree of contact with either science or practice. So for each of 5 Brazilian regions, we chose at least 1 scientist distance from practice, 1 close to practice, 1 analyst distance from science, and 1 close to science. In total, we interviewed 11 scientists and 11 decision makers. So each one of those participants produced one of those distribution of statements. To analyze the data, we calculated a pairwise correlation among the 22 distributions. And using principal component analysis, we identified groups of highly correlated distributions. Then we calculated an average distribution for each one of these groups, arriving at a typical ideal distribution for each group. We inspected these distributions by looking at salient statements, which are the statements with highest concordance or discordance within each distribution, disagreement statements, which were statements allocated differently by each group, and consensus statements, which are statements allocated similarly in all groups. So by looking at these statements and assisted by audio records of the interviews, we interpret these 3 groups and arrived at a final qualitative interpretation of the different viewpoints regarding the science-practice interface. So in total, we identified 3 different viewpoints on the science-practice interface in ecology and conservation, which are represented here by the 3 overlapping circles that will remain in the upper right corner of the presentation. Participants in the first viewpoint were named interactive partners. They were both scientists and decision makers, so 4 scientists and 6 decision makers were associated with this viewpoint. And they emphasized the importance of the integration of knowledge from scientists and decision makers, as exemplified by the participant who stated the interaction should always be bidirectional, with knowledge generated in academia and the knowledge decision makers bring from their experience being considered with the same weight. So they emphasize the importance of creating collaborative partnerships with mutual learning between scientists and decision makers. In addition, they emphasize that science is just one of several factors to be considered in decision making, and that the incentive for these collaborative partnerships must come from within organizations. Participants in the second viewpoint were called interactive technocrats. 5 out of 6 participants associated with these viewpoints were decision makers, and they assign great importance to scientific knowledge in determining decision making, as exemplified by the participant who stated it would be good if decisions were made only as a result of technical and scientific aspects. So they perceive scientists and scientific knowledge as supporters of practice, and that scientists should conduct more relevant research. They also argued that decision makers have specific knowledge on local conditions, but this knowledge was relatively assigned less weight than scientific knowledge. And they also argued that organizations of science and practice should work towards the same goal of answering relevant questions and implementing actions. Participants in the third viewpoint were named distance producers, and there were only 3 scientists who were associated with this viewpoint. They emphasized the strength of scientific knowledge in helping to solve complex problems, as exemplified by the participant who stated, environmental issues are uncertain and complex, but this cannot be an excuse for inaction. Scientific knowledge helps us to understand complexity. These participants were less willing to engage due to several commitments required by scientific organizations, so they perceived themselves more as the producers of scientific knowledge that would then be used by decision makers, and emphasizing also that decision makers should correctly interpret science. They also argued that science is just one of several factors to be considered in decision making, thus also perceiving some kind of important knowledge in decision makers regarding these other factors, and emphasized the importance of specific organizations to mediate the interaction between science and practice. So to summarize, regarding all those viewpoints, what do they have in common, or are the main points of consensus? So all viewpoints emphasize both scientists and decision makers are important actors and that should be involved in the science-practice interface, and that both hold important knowledge. Although relative weight was different, all types of knowledge were recognized by all viewpoints. They also emphasized that science and decision makers have different roles and responsibilities to play in the science-practice interface. All viewpoints also agree with statements describing that learning to deal with difference between science and decision makers is important, and that organizations should promote collaborations. And on the other hand, what are the main conflicts between these viewpoints? So the main conflicts are related to the specific roles assigned to science, scientists, and decision makers. So everybody agree all knowledge and actors are important, but what are the specific roles for each one of them? So for the interactive partners and for the distance producers, science is just one of the factors to be considered in decision making, while for the interactive partners, science is the most important factor to be considered. For the interactive partners, scientists and decision makers are holders of equally important knowledge types that should be integrated. For the interactive technocrats, science should be supporters of practice and decision makers should be users of science. For the distance producers, science should be producers of science and decision makers are interpreters of scientific knowledge. Taking all of this into account, what can we say about the main barriers to science practice linkage that are mentioned in the literature? So these barriers relate to aspects at the individual level. So for example, difference between science and decision makers in terms of values and beliefs, to aspects related to the organizational level. For example, a lack of organizational incentive to interact with either science or practice. What our results show, well, we encountered several agreements across viewpoints, a dominant viewpoint that is shared between science and decision makers, and a general disposition to deal with these potential differences, indicating these aspects related to the individual level may not be the most relevant hindrance in this case. On the other hand, we encountered that despite willingness to collaborate, participants complained of a lack of time and organizational stimuli for collaborations, and all viewpoints assigned great importance to reformulating organizations. So this indicate hindrance in the organizational hindrances may be a relevant aspect in this case. So to conclude, difference between scientists and decision makers may be less relevant than the lack of organizational incentives as impediments to effective linkages between science and practice in Brazil. And this indicates a need to establish reward systems that also value actual impact on the ground, process and products of knowledge, communication, and integration, and different forms of scholarship. With such organizational incentives implemented, successful partnerships will depend on openly debating expected roles for scientific knowledge, scientists, decision makers, and organizations, as these were the aspects where we encountered main differences across viewpoints. And this needs to be done by paying attention to recognize diversity of opinions and engage in argumentation instead of aiming at simple consensus. So I'd like to thank everyone for listening, my funders and my co-authors in the study, and I'll be happy to take any questions.
I have a question. Yeah. I'm thinking about some of the examples we heard from Naya and others yesterday. Also, Jim mentioned some of these public-private partnerships that are where, you know, there seems to be these institutional constraints you're talking about seem to have been overcome. So, do you feel that perhaps the folks you worked with in your sample, have they had those experiences, or do you feel they haven't had those experiences? And if you talk to people who have gone through cases where that kind of collaboration has happened effectively, would you be able to get interesting new insights?
Yeah. So the scientists that I interviewed were scientists working within universities in Brazil and scientific organizations. So I don't think these are people who are in organizations, like a third type of organizations that maybe allow and reward those sort of collaborations. So I think maybe, at least in Brazil, professors working within universities, I think they're still facing those sort of institutional impediments, so they are only rewarded for publishing scientific papers. But I definitely think that new sort of organizational arrangements, such as those examples that we've seen today, definitely are like the way to go, and maybe new types of, I've been talking to people like different types of organizations, not exactly a scientific organization, but somewhere in between that can actually assist connecting both sides. And I think this sort of organizations may be the organizational structure that overcomes these hindrances. But I think, at least in Brazil, it's a little bit incipient, like it's not. But it may be that I interview scientists that are actually working within like typical, normal scientific organizations.
You want to yell it and I'll repeat it for the mic?
So it seems to me that very interesting work. It seems to me that the people you interview might view the word science very, very differently. They interpret the word science differently. So I'm curious to know whether you define the term for them, so that you all talk.
So I'm going to repeat it for the other room in the archives. So the question is, did you try to agree on a definition of science, or might you and your interviewees be using different definitions of science?
Yeah, so definitely that's a really good question. Before the interview, we discussed all definitions, actually, not only science, but also what a scientist is, what a decision maker is, what a scientific organization is. So I presented the definitions I was using in my sentences, and then I asked them to clarify any questions. Yeah. So that was definitely one of my concerns. Yeah.
We're out of time. Thank you very much.
Thank you.